Time is a fundamental aspect of our lives. We organize our days, weeks, and years around it. But what is time, really? Is it a constant, unchanging quantity? Or does it vary depending on our circumstances? One of the most intriguing phenomena related to time is time dilation, a concept that has fascinated scientists and philosophers for centuries. In this article, we'll explore what time dilation is, how it works, and the mind-bending consequences it has for our understanding of space and time. What is time dilation? Time dilation is a phenomenon in which time appears to pass slower or faster for objects that are moving relative to each other. It is a consequence of the theory of relativity, one of the most revolutionary scientific theories ever proposed. According to the theory of relativity, space and time are not separate and independent entities, but are intertwined in a single fabric known as space-time. Space-time is not a fixed background against which events take place, but is itself subject to change depending on the presence of matter and energy. The theory of relativity predicts that time dilation occurs when two observers are moving at different speeds relative to each other. For example, if an observer on Earth watches a spaceship traveling at a high speed, they will see that time on the spaceship appears to pass more slowly than time on Earth. Similarly, an observer on the spaceship will see that time on Earth appears to pass more quickly than time on the spaceship. This phenomenon is known as time dilation. How does time dilation work? The key to understanding time dilation is the concept of relative motion. According to the theory of relativity, there is no such thing as absolute motion. The motion of an object can only be defined relative to another object. For example, a car traveling at 60 miles per hour is only moving at that speed relative to the ground. If you were traveling in another car at the same speed, the first car would appear to be stationary relative to you. The theory of relativity predicts that the faster an object moves, the more time dilation occurs. This means that if you were to travel in a spaceship at very high speeds, time on the spaceship would appear to slow down relative to time on Earth. This effect becomes more pronounced the closer the spaceship gets to the speed of light, which is the maximum speed that any object can travel in the universe. The reason for this effect is that as an object moves faster through space, it also moves through time at a slower rate. This may seem counterintuitive, but it is a consequence of the fact that space-time is not a fixed background, but is itself subject to change. As an object approaches the speed of light, it takes more and more energy to keep it moving, and this energy causes time to slow down. Consequences of time dilation. The consequences of time dilation are mind-bending and have been the subject of much scientific research and speculation. One consequence is that time travel to the future is possible, at least in theory. If you were to travel on a spaceship at very high speeds for a few years, time on the spaceship would appear to pass more slowly than time on Earth. This means that when you return to Earth, you would find that many more years had passed than you had experienced. In effect, you would have traveled into the future.